Good morning, students. In the today's session, we'll learn about protocols. That is transport layer protocols. Okay. Here we have to learn about what are the two different types of transport layer protocols. Here we have the TCP and UDP. These are the two transport layer protocols. In the today's session, we'll learn about what is user datagram protocol. Okay. And here, what is mean by this user datagram protocol? It is a here in the previous session, which we already learned, the connection-oriented protocol is a TCP, and the connectionless transmission, the UDP is the best example that we have learned in the last session. Okay, and what is mean by this UDP? It is a connectionless protocol. Okay, and it is for the unreliable transport protocol. Okay, and here the UDP is a very simple protocol using a minimum of overhead. Okay, this performs very limited error checking. Okay, and the UDP is used when a process wants to send a small message and does not need any reliability. Sending a small messages by using UDP takes much less interaction between the sender and receiver. Okay, and when compared to TCP and SCTP, the UDP will take less time for the interaction between the client and server. Okay, and the well-known ports for the UDP transmission. Here, these are the well-known ports for the UDP transmission. Okay, now what we have these well-known ports. Here the port number 7 is for the echo. It is a echo protocol. That means the echoes received a datagram back to the sender. Okay, and what is mean by this 9 is it discard protocol. What is here? It discards any datagram that is received. Okay, now what is mean by this 53 is a port number. The protocol for the 53 port number is name server, and it is going to provide us the domain name service. Now, what is mean by this boot peers? Okay, here, this is a server port number for the bootstrap information. The port number is 67 and the port number is 68 for the client port to download the bootstrap information. And what is mean by this SNMP? It is the port number for the SNMP is 161 and it is a simple network management protocol. Okay, now just we have learned about only the port numbers. Okay, now here this is a simple structure for the UDP packets. Okay, that means we are going to call the UDP packets are also called as a user datagrams. The datagrams are a fixed size, header of length 8 bytes. Here for each and every datagram we have the header part, then we have this data part. Okay, and here we have the source port number as 16 bits and the destination port number is 16 bits and the total length is 16 bits for the source number, and for the checksum it is the 16 bit. This is a simple structure for the user datagram. That means we can say simple packet structure. Okay, and here now we'll see about each and every field of the user datagram. What is our first field? It is a source port number of 16 bits. Okay, now, what is meant by this source port number? It is a port number used by the process running on the source host. Okay, and if the source host is a client, the client sending a request. The port number is an empirical port number requested by the process and chosen by the UDP software running on the source host. And if the source host is a service, a server is going to sending a response. Okay, and the port number is a well-known port. Now, what is a destination port number? Whenever we have learned about the user datagram, there we have the source port number as well as the destination port number. And this destination port number means it is a port number used by the process running on the destination host. Okay, if the destination host is a server, then the client sending a request. The port number is a well-known port number. And if the destination host is the client, then it is going to send response back to the client based on the request. And as we have learned in the last session, the number of this source and destination port number starts from 0 to 65,535. Okay, and it is given by the IAN. Okay, and here the main important concepts which we have to learn about the UDP operation are: the first one is the connectionless service and no flow and no error control. and encapsulation and encapsulation, and what is meant by this queuing. What is meant by this connectionless service? Here in the last session, we have learned there we have a connection-oriented service as well as this connectionless service. The connection-oriented service is provided by the transmission control protocol, and the connectionless service is provided by the UDP. That means we have given the best example for the connection-oriented is the TCP, and the best example for the connectionless service is the UDP. Okay, here this UDP is going to provide you a connectionless service, and there is no connection establishment and no connection termination. Okay, that means each user datagram sent by UDP is an independent datagram. Now, the user datagrams are not numbered. Each user number can travel on a different path. Okay, now there is no relationship between the different user datagrams, even if they are coming from the same source process and going to the same destination program. And the UDP processes are capable of sending short messages only. Okay, and the second concept for the UDP is there is no error flow and error control. Okay, there is no error control mechanism in UDP except for the checksum. Okay, and there is no flow control in UDP because the receiver may overflow with the incoming messages. Okay, and the sender does not know if a message has been lost or duplicated, because there is no proper numbering between the for each and every packet, and it is a connectionless service. Okay, and when the receiver detects an error through the checksum, the user datagram is silently discarded. Okay, and what is meant by this encapsulation? To send a message from one process to another process, the UDP protocol is going to encapsulate, and then it is going to decapsulate the messages in the IP data. And what is meant by this queuing? Queuing means what? Here, the queues are associated with the ports in UDP. The queues are associated with each and every process. What is meant by this process means here, whenever you are executing an application program, it is called as a process. Okay. And now see here, the queues are created when a process is started. Then there are two types of queues are created. One is an incoming queue, another one is an outgoing queue. Okay. A process wants to communicate with multiple processes. It obtains only one port number and one outgoing queue and one incoming queue. And see here, this is a UDP protocol. It is a client and it is going to provide you one outgoing queue and then one incoming queue. Okay. And here it is at the client side, and at the server side also the same. Okay. And what are the advantages or what are the uses of UDP protocol? Here, this UDP is suitable for a process that requires simple request response communication. Okay, with little concern of flow and error control. And this UDP is suitable for a process with internal flow and error control mechanisms. And this UDP is suitable transport protocol for multi-class. Okay, and this UDP is used for management processes such as SNMP, like simple mail transmission. Okay, and what is mean by this UDP? This UDP is used for route updating protocol. Okay, that means here this is the route information protocol. Okay, and we'll see in the about the TCP. We'll see in the next session. All the best.